Hi, this demonstration is to show you about conditional tasking. The idea with this one is that we have one button and it does two things. The first button push will be during daytime, and what we want to happen is just the garage lights to turn on. Then at night time we want that same button to turn a pathway to our bedroom on. We call this a conditional task because the condition is time. Now we will need a time clock in our network. Okay, in this example what we want to do is the welcome home task to turn on a pathway to the bedroom, but we only want that to happen at night time. During the daytime we want only the garage to turn on when we press the welcome home button. To achieve this, we're going to need a time clock. We will configure the time clock to send a message at sunrise and sunset, and we're going to use a dummy message at sunrise to set to say Area 200 preset 1, and at sunset we will say Area 200 preset 2. So task 5 and 6 here are going to live on our panel in the garage. Task 5's job is to listen for the Area 200 messages from the time clock, and we're going to use our start command to do that. We can see here that we are listening for 1C messages for Area 200. The X are wildcards, so we don't mind what those values are. We are going to collect all 1C Area 200 messages. To understand what is really happening with this task, we need to know a little bit about our DINET string. Let's look at our monitor window to see exactly what the Area 200 preset 1 and 2 messages will look like from the time clock. Here we can see they are 1C messages. 1C messages means that it is a logical message for an area number. So we have 1C, and then if we calculate what 200 is in hex, we will find that it is C8. Okay, so you can see that 200 in decimal equals C8 in hex. The next byte here is the fade rate, and then the next one along is our preset. So if we compare the preset 1 message to the preset 2 message, we can see that it is exactly the same except for the preset byte. Each of these bytes has a name, so I know which one I'm talking about. Like your house on your street has a number, each of these bytes has an address too. So the first one is called @0, the second one is called @1, the third one is called @2, the fourth is @3, the fifth is @4, and so on. So, knowing the conditional tasking is if-then, and we need a condition to compare to, I can use the byte in @3 to be my flag, or my if-then. We'll write some code so that if it's a 0, then we'll branch to one label. If it's a 1, then we will branch to another. The next really important thing that is important to remember is each of our devices has its own memory. The way that that memory works is kind of like this. Imagine the DINET string on the bus is like the books up here on the bookshelf. When you have lots of information on a bookshelf, you can't keep all of that on the desk as there isn't enough room. We take each book down onto the desk and use it when we need it. Then we put it back onto the bookshelf when we are done. The DINET string with all of the bytes are like the books on the bookshelf. In our devices we have what's called an accumulator, which is like the desk. We can take one of the bytes down at a time, so when I want to use the byte in @3 as my flag, then I am going to use the accumulator. The third really important thing that we need to know before we break this code down is we have memory locations on each device. We have 64 memory locations, and they are called ~0, ~1, ~2, and they go all the way to ~63. We use these memory locations to store our byte information in them so we can later go back and use them as our flag to compare and then branch to our state of day or night. Think of the tilde location as a safety deposit box, and you have 64 of them that you can choose from. Okay, now we have covered those 3 important points, let's have a look at our code again. Okay, we'll start down here. We can see that we have the labels day and night. They are going to be our 2 states. In day, we can see that only the garage is turning on to preset 1. Under the night label, we can see that we have the pathway turning on from the garage through to the bedroom. We already know about null. See, that's in our code here. If we didn't have null, then the code would do what we call running on, and our task would continue on without waiting for the next button push. We don't want that to happen, so we need null there. So from line 76 down, we should feel pretty comfortable with what's going to happen. We don't need null after the night label because the brackets act the same as null. Okay, so if we're comfortable with what's on line 73 down, then we can look how we are going to compare and branch to those labels. Let's look at task 5. Task 5, line 58, is listening for the area 200 messages from the clock. Line 59, we have a new command, which is LDA. That means load the accumulator. So we're going to load the accumulator with the byte that is in @3. Line 61, STA, means store, and the tilde symbol means we are going to store that value that we loaded from @3 to memory location or tilde location 0. Remember, I could use any memory location from 0 to 63. Okay, so task 5's job is to listen for the time clock's area 200 messages and then store the value that was in @3 into tilde 0. At sunrise and sunset, that value is going to change from a 0 to a 1 each day. Task 6. This is the task that gets assigned to the button in the garage. Line 67. LDA is loading the accumulator with the value that we put in tilde 0. Line 68. CMP means compare. Hash means a physical value, so we are going to compare to a physical value of 0. That means, is it a 0 in tilde 0? If it is, then line 69, BRZ, means branch to the label day. If it was a 0 that was in tilde 0, then the code will branch to day and area 2 will turn on to preset 1. If it's not 0, then the code runs on and line 70 is CMP, which is compared to hash 1, which means, is it a 1 in tilde 0? If so, then BRZ means branch to the label night and the pathway will turn on. So at this stage, I should have branched at either label day or night, and either state would have occurred. Okay, so let's see this in action.